Hi grade 11s and welcome to this video. In this video we'll be working on the Mathematics Term 3 test, and this is for September 2022, specifically from the Eastern Cape province. The marks allocated to this paper is 50 marks and the time is 1 hour. Okay, so you can see the instructions. Just make sure to round off to 2 decimal places unless stated otherwise, and the diagrams are not necessarily drawn to scale. Okay, so with that being said, let's get into this video. Question 1 is on measurement, and it says, in the diagram below, a pyramid is mounted on top of a rectangular prism with a square base. Okay, so we've got this pyramid over here and it's been put on this rectangular prism. The height, which is h, of the pyramid is 0.6 meters. Each side of the prism is 5.2 meters and the height of the prism is 2.5 meters. So they also give us some formulae and they tell us the volume of the prism, which is 1 over 3 area of the base times height. Okay, that makes sense. So the volume of the prism, you take the area of the base first and then you'd multiply it by the height, and that would give you the entire, not really the volume of the pyramid yet, okay? But then when you say times 1 over 3, then it's going to give you the volume of the pyramid. Because naturally, if you say the area of the base times the height, what you're actually calculating the volume of is of this prism, okay? And then once you finally say times 1 over 3, because the pyramid is only 1 over 3 of this entire volume that is highlighted, then you get the volume of the pyramid, that. And then the volume of the prism, okay, area of the base times height, very simple. Okay, just like the way that worked, just without the 1 over 3, because this is an actual prism. And the first question, 1.1 says, calculate the total volume of the figure. So looking at this shape, how do we find the total volume? Well, there are two 3D shapes in it. So you need to find the volume of this pyramid and then the volume of the prism, and then we add them together. So let's find them separately. We'll find the volume of the pyramid first. Okay, take our formula, which says 1 over 3 area of base times height. So we'll take 1 over 3 and then multiply by that area of the base multiplied by the height. Okay, so 1 over 3 times the area of the base. The area of the pyramid's base, remember that this is 5.2, so this is still 5.2 as well. So 5.2 by 5.2, that's what we'll say there. So 5.2 multiplied by 5.2, then multiply by the pyramid's height, okay? The pyramid's height is that 0.6. So that's multiplied by 0.6. And we're just going to go ahead and put this on the calculator. Okay, and that is 5.408. Okay, and it is in meters cubed. So that is the volume of the pyramid. And then we would need to get the volume of the prism. Okay, so let's find that. So let's find the volume of the prism. That prism is really just simple. It is just the area of the base, again, times the height. So the area of the base, that is 5.2 by 5.2. So we say 5.2 times 5.2, or 5.2 squared, and then multiply by the height of that prism, which is 2.5. So that's 2.5, and let's get our answer. And that is 67.6 meters cubed. And so to find the volume of the entire figure, we just add these together. So the volume of the figure is finally found by just saying 5.408 plus 67.6, and let's get our answer. And that is 73.0, and that's going to round the 0 up to a 1. So 0.1 meters cubed, and that is our answer. Okay, moving on to the next question. The next question says, calculate the slant height of the pyramid. So the slant height. The thing about the pyramid is there are two heights that you can consider, but if they ask you for the slant height, you can clearly see they're going to ask for the total surface area, because that's what we would use the slant height for. So the slant height, it's not this height that we were referring to where we go from the highest point of the pyramid and then down to the ground of the pyramid. It's not that one. But this will be helpful, okay? The slant height is the height of each triangle that we see here. So with this triangle, if you go from the highest point of this triangle and then you go down to the base of the triangle, and it is a line perpendicular to that base, this is the slant height. So how would we find that? Well, with this is how we can find it. You see how this is the height of the pyramid? So it means that if we were to connect on this square that we have here on top, if we were to connect from here to that point, this line would be perpendicular to this line. But you see this point here, okay? It is at the center of the square that we have. Since it's at the center of the square, we can actually find the length of the side. And here's why it's important. We know that this is the slant height. To find the slant height, we have a right angle triangle here. Because this is a 90-degree triangle, we can use Pythagoras to find the slant height. If and only if we have this side, which we do have, okay, it's 0.6. And if we're at this side, we can easily find this. So you see this, because this is at the center, it means from here to the edge of this square, it is exactly half of whatever this length is. Because this is 5.2 meters, so this would be a half of it. If you went from the center to there, there's the other half, and then this is the full 5.2 meters. Okay, so 5.2 meters divided by 2 would give us the length of that side. And let's find that first. And that is 2.6 meters that we have there. Okay, so we know that this little part over here is just 2.6 meters. And what can we do now? So to find this slanted height, we will use Pythagoras, knowing that this is 0.6 meters. So we'll say that slant height, we can call it S. So S squared would simply be found by saying, take this side squared, 0.6 squared, plus 2.6 squared. Okay, so 0.6 all squared plus 2.6 all squared. And then slant height squared equals, and that is 7.12. And then finally find that slant height by square rooting both sides. You don't have to consider any negatives since we are working with lengths. Okay, so when we find the square root of this, you can just say square root of your answer. And then there we go. It is 2 point, and that 8 is going to round the 6 up to a 7. So this is 2.67 meters, and that is the slant height. Moving on to the next question. Then question 1.3 says, determine the total surface area of the figure. Okay, I'm just going to get this figure down because there's some things we would need to just consider. So we want the surface area, the total surface area of the entire figure, meaning we need to find the surface area of the pyramid and the prism. But we need to think about it like this. If they asked us for the total surface area of the figure, then considering this figure as a fixed 3D shape, okay, that pyramid has been placed on that prism, then it means that to find the total surface area, you have to consider all the outside parts of it, all the exterior parts of it. Okay, so let's think about everything that would be considered. We would consider the bottom because it counts as the exterior. Okay, so you see that shape over here, we need the area of the shape. Then we would also consider the sides that we can see. Everything that is outside the shape you would consider. We'll take this and we'll consider that. You can think about it like painting the shape. If you had to paint the shape, you would need to paint this side. You would need to paint the back side, of course, and these sides as well. You would need to paint that bottom, okay, on the outside. And you would also need to paint those sides over there, that side, this side. And then with the pyramid, you need to paint its outer sides as well. So we need that back part, okay, that triangle that we can see there. We need this side part, basically everything that is on the outside. So we just need to consider this carefully. Okay, so I'm not going to find things separately. I'm just going to put them all down as one. So to find the total surface area of this figure, let's go. We are going to first consider the bottom, the base. So we need the area of the base. So we're going to take the area of the base and then say plus, and then let's focus on the sides. Okay, so the sides of the shape. So you can see that this creates a rectangle because it is 5.2 meters by 2.5 meters. Okay, so 5.2 meters and then by 2.5 meters. We'll take that. So there are exactly 4 parts of that. There's this part, 2, the back there, 3 and 4. So to find that, we'll say 4 multiplied by those sides, okay, the rectangles. Okay, I'll just say area of rectangles for now. And then we also need, for the pyramid, we need the area of all these triangles that we have. So the area of the triangles. Okay, so the area of the base, we'll put that in a bracket, that is just going to be this side times this side. The base is really a square. So you could just say 5.2 squared, okay, 5.2 times 5.2 plus the area of the rectangles. Remember, there are exactly 4 rectangles, so that's 4 multiplied by, and then it's side times side, which is 5.2 multiplied by 2.5, okay? And then plus the area of the triangles. You see with the triangles, how many triangles do we have in this shape? We have exactly 4 triangles because it has a square base, okay? So that's one face over there, 1. This face over here, 2, 3, and 4 at the back. Okay, so we have 4. So 4. And how do you find the area of a triangle? And that's the only thing we really need to think about. The area of a triangle can be found by saying a half multiplied by its base, multiplied by its perpendicular height. And so to find this, we're just going to say a half multiplied by its base. And what is the base of this triangle? That will be this 5.2. Okay, it's the same all through. So 5.2 here, that is the base. And then multiplied by the slant height. And that is the height we're considering because we are only considering the outer part. So this triangle has a height of this that we just found previously, and then this is the base. Okay, so we'll need 4 of those. So we'll just go ahead and say 4 multiplied by a half times the base of 5.2 times the perpendicular height that we found, which was 2.67, and this should give us the area of the outer part of the shape, since they said the total surface area of the figure. So I'm only going to calculate all the parts on the exterior. Okay, that would be of the entire figure. Okay, and you can see that the final answer is 106 point, and that 8 is going to round up to a 1. So that's going to be 106.81 meters squared, because this is area at the end of the day. Okay, and that is our answer, and that is it for question 1. Question 2, statistics for 20 marks, says 2.1, the following are the heights in centimeters of 11 soccer players. So it looks like with these heights, they haven't really put them in ascending order, so we need to still order them. And 2.1.1 says, draw a box and whisker diagram. Use the addendum. Okay, so let's just go ahead and put them in order first. The smallest number here looks like that is 100, and then we're done with that. And then 143, done with that. Then followed by 150, and then 155, okay. And then we are in the 160s now, so 164, and that is the only one in that range. And then we have 171, and there are 2 sets of this, 171 and 171. Those are done. And then followed by 180, and then 182, and 188, and then lastly 190, and that is it. Okay, just ensure that you have the same amount of numbers that you had. Here they are 3, 6, 9, 11 numbers. Okay, and then just make sure it's the same thing here. 3, 6, 9, and we do have 11 numbers as well. Okay, so this is what we have. And so to draw your box and whisker diagram, you need your 5 number summary. So that is the minimum value, which we can clearly see. So I'll mark them as they are. There's no use of doing all those calculations. We just need this. So we can see the minimum value, the lowest is this. So that is our minimum. Our maximum is 190. And then we need Q2. If you get Q2, it's easier to find the other quartiles. Okay, so Q2 would be the middle. If there are 11 numbers, right, it means that if you divide by 2, you see that you're going to get 5.5, meaning your numbers are going to be like this. There'll be 5 on the left and 5 on the right, and then that 6th number is the middle. So find number 6, and that's 1, 2, 3, 4, 5, 6 this is Q2. Okay, so we'll take that as Q2. And now to find Q1 and Q3, this is how that works. You see, if Q2 is marked here, this is an actual number here. We didn't have to add two numbers and then divide by 2 because there are an odd amount of numbers here, 11 numbers in total. You're going to find Q2 by looking at the lower half of your data set. The lower half of your data set will start from this number, the first one, and then it's the number before Q2. Since this is 171, it's these. So there are exactly 5 numbers here, and then the middle of this lower half would be Q1. So the middle is 150, that is Q1. And then looking at the upper half, there are also exactly 5 numbers here. The middle of that would be Q3. So that would be 182, and that is Q3. Okay, so there we go. Our 5 number summary is complete. And let me get the addendum. Okay, so this is what we have. And let's go ahead and draw this box and whisker diagram. So starting with the minimum value, which is exactly 100, we just put that down. So you can put down a dot because it's the minimum value. And then we have Q1, which is 150. Okay, so 150 is here. You can just put that down, 150. And then Q2 is 171. So that's 171, just right after 170. But because it's not on the number line, I'll just write 171. And then Q3, which is 182. That's also not on the number line. I'm just going to write it down, 182. And then 190, which is there, which is the maximum. So you put a dot for that maximum. And then connect your quartiles. So they create a box we have there. And then finally, draw your whiskers. So connect the box finally to the minimum and the maximum value. And there we go. This is our box and whisker diagram. Moving on to the next question. Question 2.1.2 says, hence, state whether the distribution of the data is symmetrical, skewed to the left, or skewed to the right. Okay, so looking at this data, you can judge this looking at the box and whisker diagram. Okay, so we need to focus on the quartiles. So you're just going to focus on how close Q1 and Q3 are to Q2. So do you see how this is? We can clearly see this is not something that we have to actually calculate. Sometimes they're close together, then you have to get exact numbers just so that you can just see. But with this one is very clear. Look at how you can think about it. Think about you are here, right? And you are standing facing the front. Okay, so this is your front. This would be your what hand side? Is this your left or your right hand side? This would be your right hand side. And then this would be your left hand side. So you're going to base this on how close Q2 is to Q1 or Q3. Is Q2 closer to Q1 or to Q3? It's closer to Q3. So it means that this is skewed to the left. And that would be our answer. So we'll say that it is skewed to the left. Okay, so that is our answer. Moving on to the next question. 2.1.3 says, write down any outliers. Okay, so let's just see if we have any outliers. Since they've already asked us to draw the box and whisker diagram, we can just use this to identify our outliers. So the outliers would be numbers that fall far away from where the rest of the numbers are. Okay, so the range of the rest of the numbers. So these are numbers that are really just extremes. They could be a little too high from where the rest of the numbers are, or a little too low. So in this case, from the way it already looks, you can already see that stretch. So focus on where the box is, right? And in this case, we're going to consider the minimum and maximum value because they would be the ones that we would expect to be significantly far away from the rest of the data. In this case, you see the maximum, 190. It's not really an outlier. You see, look at how close it is to the next quartile. So Q3 is 182. The maximum is 190. That is still fine. Okay, that still follows the trend of the way our data looks. However, look at Q1, 150. Look at the minimum, 100. That is an outlier. Okay, there's a significant distance from the lowest value to the next where Q1 is marked at. Okay, so in this case, we can visually see that the outlier is 100, and we'll put that down. Our outlier is 100, and that is our answer. Moving on to the next question. Question 2.2 says, the following data shows the ages of 10 spectators in the VIP room. Okay, 2.2.1 says determine the value of x if the mean is 36. Okay, use what they have given you. They've given you the info, only x is missing, but then they tell you that the mean is 36. How do you calculate the mean of a data set? You add all the data points and then you are going to divide by the number of data points that we have. In this case, that is 10, okay? 10 people that we have here. And then you would see that the only thing missing here would be x because we don't really have a value for this yet. However, we do know what the mean is. It is 36. Okay, so let's go ahead and add. I'm just going to add the numbers. So add all of that with all of that. And let's put that there and we'll just say this is x plus all of that, the sum of those numbers. Okay, and they add up to 324. So all we're going to say is we already know the mean. This is how to calculate the mean. That is the mean. So 36 is equal to x plus and then 324 over 10. And then how do we get to the x? We get to the x by first getting rid of this 10 in the denominator. So to get rid of that 10, you're simply going to multiply by 10. Okay, so multiply by 10, but this is an equation. What you do on one side, you must do on the other side. So this becomes 360 equals x plus 324. So to solve for x, again, you're just going to isolate the x, take that over. So we're just saying that x is equal to 360 minus 324. And finally, we'll just say x is equal to and put down our answer. Okay, which is indeed, that's going to be 300 gone 60 minus 24 is indeed 36. And there we go. So x really is equal to 36. Moving on to the next question. Okay, the next question says, hence determine the standard deviation. And this is for 2 marks. So they expect you to use the calculator. Okay, so we're going to have to fill in this data, but now we know that x is 36. And let's go ahead and do that. So on your calculator, you're just going to go for mode and then stat. Then you're going to go for the option that says 1 VAR because we are working with a single variable data set. And then input your values. Once that is in, press AC, Shift, and 1. And you're going to see some options. Just go for the option that says VAR, variable. And you're going to look for the standard deviation. Okay, so the standard deviation is going to look like that. So go for that option. And our standard deviation is 8 point. And that is going to round up to an 8. So 8.88. And that is our answer. Moving on to the next question. Question 2.2.3 says, how many people have ages which are more than 1 standard deviation from the mean? Okay, so we're going to look at a standard deviation from the mean. Now, notice how they didn't say 1 standard deviation above the mean, but in this case, it doesn't really matter because they said more than 1 standard deviation from the mean. Here's what I mean. So with standard deviation, okay, we're saying 1 standard deviation from the mean. So we're looking at the mean and we're going a standard deviation from the mean. We could go a standard deviation more than the mean. Okay, so that will be mean plus standard deviation. So a standard deviation higher than the mean, or we could go a standard deviation less than the mean. So what we would get there would be, to find that, would say the mean minus a standard deviation. And to get this one, we would say the mean plus a standard deviation. But because they already said more than 1 standard deviation from the mean, and we were looking for numbers that were greater than this, okay, more than this, then unfortunately, you see how that's going to lie in between these numbers. That number may be greater than this, but it would not be greater than that. It wouldn't count as a standard deviation more than the mean when looking at this. So what they clearly mean by this is we're looking at this and we're looking for numbers that are more than whatever this gives us. Okay, so more than a standard deviation from the mean. Okay, so let's go ahead and find this. We're going to find the mean plus the standard deviation first, and then find the numbers that are more than this or greater than this. So the mean is 36. We'll say 36 plus 8.88. And we'll just get our answer. So that's going to be 44.88. And we just need to find numbers that are greater than this. Okay, so let's go look for numbers that are bigger than this. So, numbers greater than this. 47, yes. 34, no. 28, no. 36, no. And 55. And then that's it. We don't really have any other numbers greater than this. So focus on what the question is asking. They said, how many people have ages which are more than one standard deviation from the mean? And there are exactly how many people? 2 people. Only 2 numbers were greater than this. So finally say, there are 2 people. And that is our answer. Moving on to the next question. Question 2.3 says, the following table shows the heartbeats per minute of 100 adults of between the ages of 20 to 60 at a soccer match. Heartbeats per minute. Okay, so this is the intervals that we have. And then the number of individuals and then the cumulative frequency. Okay, 2.3.1 says complete the cumulative frequency column on the addendum. I'm just going to complete it here. Okay, so we can just work off of it. So the cumulative frequency column is completed like this. You just use the frequency. So with the 4, the only thing we're adding is just 4. So we'll just rewrite this as 4. And then you're going to say 4 as 18. Okay, and then that gives us 22. And then 22 plus 26, which gives us 48. And then 48 plus 27 adds a 250. So plus 25, that is 75. And then 75 plus 11. So this gives us 86. And then 86 plus 7. Take out a 4 from that. That is 93. And then 93 plus 5. 98. And finally 98 plus 2. 100. Okay, so there's our cumulative frequency column completed. Moving on to the next question. Question 2.3.2 says, draw an ogive, a cumulative frequency curve, to represent the data. So use the grid in the addendum. Okay, so let me go ahead and get that first. Okay, so there is our grid, and you can just title this ogive. So we have that now. And let's go ahead and start plotting. So with these, this is how we're going to plot it. You see these intervals, you know that they usually write this as, for example, with this, they would usually say, okay, these are heartbeats per minute. Let's say it was X. They would say X is greater than 51, but less than or equal to, or maybe say greater than or equal to 51, but less than 60. Okay, and we would just move like that. And then the next one, X is greater than or equal to 61, but less than 70, and so on. So it still works the same. And so with this, what is going to happen is these values, okay, are your X values. And they're going to go with these cumulative frequency values. So 60 goes with the 4. 70 goes with this 22. 80 goes with the 48. And you see how they're all going to be paired up. So with that, just keep in mind that this 51 over here, right, that number there will always go with a cumulative frequency value of 0. Okay, so this is the X value, the Y value that goes with this is 0. Okay, so let's go ahead and plot. It's going to be first, the X value is 51, the Y value is 0, so 51 and 0, and we'll plot that down. So that's about here, 51 and 0. And then next we're just moving here, 60 and 4. Okay, so that's 60 and 4. So you're just going to go 60 here, and then 4 units up. This looks like 5, so just right below it would be 4. Okay, and then we have 70 and 22. So 70 and 22, and then I'm just going to fill in the rest because I was just trying to see, you know, how these work, how the numbering is working. Okay, so I'm just going to fill in the rest. It's going to create some sort of curve. Okay, so it looks like that, and then you're just going to connect it. So connect it, and it's going to be a curve. Okay, and that is our ogive. Moving on to the next question. Okay, question 2.3.3 just says we need to read off the graph. We need to find the median. So the median is also known as Q2. So this is marked at half of your data set. So your data set has already been ordered, put in ascending order because this is already group data. And so we will find the position of Q2 first. So to find the position of Q2, we find this by remembering the amount of people in this survey, okay, and we know there are exactly 100 adults. Okay, you can also see that here. So if they didn't give that info, you know that it's going to be the final amount in the cumulative frequency, since the cumulative frequency column is just adding up all the people that we have in all these categories. So we're going to take 100 and we're going to find half of this, because we know our info, our data, just like we see in the box and whisker diagram, it is split into quarters. And then, we analyze this, we can make certain decisions based on the info that we have. And so Q2 marks 50% of your data. So you can see that if we have a specific number here, right, it just means that 50% of the people would have had a value less than that and 50% would have had a value higher than that. Okay, so just Q2. So find the position first, and we find that by saying we will find this person at a half times the total of 100 people. So that would be 50. So Q2 is marked at the 50th person. So let's go ahead and find this. So you're going to go to, because we know this is the 50th person, okay, that is a cumulative frequency value, people. So we go to the cumulative frequency, okay, axis, and we are going to mark 50, and then you're going to run to the ogive, and once you hit the ogive, you go down. Yeah, this one just kind of looks like it's 80. I want to say 80, but it's probably not 80 because we already had a point with 80. So yeah, there's no way that that is on the graph. It just depends on how it was drawn. Okay, so from the way I drew it, it looks like 80. But what I actually think is going on, because there's a next data point here. This one was here. So it would have curved and then it would have hit this and then gone down and into the next. So that would be somewhere here. Okay, let's just say it was here. And I won't take that as 80. I'll take it as roughly 81, maybe. Okay, do you see why I'm saying 81? Because I see that when I drew this, I went a little high instead of trying to focus on connecting those. So I should have gone from there and then connect. Then it would have been a bit lower. So I'm going to take that median as 81, roughly 81. Okay, so 81. It's just one of those ones that I can't really just say, oh, maybe it's about 80. It can't be about 80 because we actually have a data point with 80. So it wouldn't make sense. So Q2 is 81. Okay, and that is our answer for Q2. Moving on to the next question. The last question says, how many people's heartbeats were 105 and more? Okay, so 105 and more. So here we know that our heartbeats are on the x-axis. We're going to go to 105, which clearly is here. Okay, so this is 105. And we need to find out how many people's heartbeats were 105 and more. Okay, I need to just see, did I do the same thing I did there? No, this one seems a little more accurate. So I'll just take it like that. So we want to find out how many people. They gave us an X value. We need to give them a Y value. So the number of people whose heartbeat was about 105, we went up to the ogive. And once you hit the ogive, you would have to go to the left so you can see the amount of people in this category. So we go to the left. That looks like, okay, so about 88. Now, this just depends on how this was drawn. There would be a range of answers they would accept. So you could still just take it like that. Okay, so I'll say roughly 88 people. But then they didn't just say, we want to know how many people had a heartbeat of about 105. They said 105 and more than 105. So this is how we would find this. So at 105, we find there are 88 people, but we need to find out the people who had a heartbeat of higher than this. So that would be everybody who got more than that. We know that the highest heartbeat was 130, right? And then if you went to the left, okay, you can see that there are a total of 100 people in total. So looking at this, that would be everybody who had a heartbeat of less than 105. And then above this would be people who had a heartbeat of more than. So to find those people, you say 100 minus the 88 people. And then that would be it. Okay, so I'll just take it like that. 100 minus 88. And we will get that. 100 minus 88 is equal to, and we have 12. So about 12 people, there will probably be a range of answers that they will accept. And that is our answer for that. And that is it for question 2. Question 3 is based on probability, and 3.1 says, given that P of A, the probability of A is 0.4, probability of B is 0.35, Probability of A and B is 0.14. Determine the probability of A or B. Okay, so you see that we have an intersection here, and they want us to find the probability of A or B. So the rule with the probability of A or B, if you have an intersection, is the probability of A plus the probability of B minus the probability of A and B. Okay, because this is a case where we have events that are not mutually exclusive. So there is an intersection. So this is A and this is B. We're taking the entire probability of A, all of that, plus the probability of B, the entire probability of B. But now do you see the problem with that? When we said the probability of A, it included that intersection. If you say plus the probability of B, it will still include that intersection again. And that's why we say minus the probability of A and B, so we can remove that intersection that was added twice. Okay, so let's go ahead and do this. Probability of A was 0.4 plus probability of B 0.35 minus 0.14, and let's get our answer. And our answer is 0.61. Moving on to the next question. Question B is asking for the complement of A, okay, the probability of not A. So to find this, we will say this is equal to, you see, they're just saying the probability of not A, meaning you're just going to exclude everything that is A. So we're going to just exclude A. That'll be everything else except for A. So if we had to highlight that, that is everything else except for A. So if we had to add up everything here, so including whatever is outside, it would add up to 1, 100% of everything we have. So as a decimal, it adds up to 1. And we would take 1 and say minus, because we don't want A, we say minus the probability of A, and that would give us the complement of A. So this is equal to 1 minus, and probability of A was 0.4. So that's 1 minus 0.4, which we know is 0.6, and that is our answer. Moving on to the next question. Question 3.1.2 says, are the events A and B mutually exclusive? Give a reason for your answer. So are they mutually exclusive? No. Okay, mutually exclusive events are events that do not intersect. Okay, they are excluded. They don't intersect. These have an intersection. We saw that with the probability of A and B. So we can just show them and tell them, no, they are not mutually exclusive. And I guess our main argument here would be because the probability of A and B is not a value equal to 0. Okay, it's not equal to 0, meaning there is actually an intersection. Okay, there's not really any words needed. If you think about it logically, that's really all. Moving on to the next question. Then question 3.1.3 says, are the events A and B independent? Give a reason for your answer. So how do we spot when events are independent? Well, if the probability of A and B, since we know there is an intersection, is equal to the probability of A multiplied by the probability of B. Okay, we know what the probability of A and B is. That was 0.14, right? And let's go ahead and find out what the probability of A multiplied by the probability of B gives us. So if you take 0.4 multiplied by 0.35, so 0.4 times 0.35, let's see what that gives us. That gives us 0.14. So there we go. We have proven that they are equal, therefore they are independent. I'll just go ahead and take that as a conclusion. Okay, so take that and say, therefore they are independent. Okay, and that is our answer. Moving on to the next question. Question 3.2 says, Paul visited his friend on their farm. They have a herd of 200 Nguni cattle, and then he counts 130 cattle with black patches. Okay, so we need to look at the categories they're telling us. So 130 with black patches, 110 with brown patches, and then X cattle with both black and brown patches. Okay, it seems like it's only black and brown patches that we're looking at. And then there are 5 cattle with neither black nor brown patches. Okay, so clearly we just have 2 categories, and then there's 5 with neither. So 3.2.1 says, draw a Venn diagram to represent the above information. Okay, so put our rectangle down And we clearly just have two categories. So yeah, we're going to just have to write the actual words, black and brown. And they're just two circles. Since we do have an intersection, okay, black and brown patches, we're going to have two circles and they intersect. Okay, so we know that there are a total of 200. We'll just keep that in mind. And then they also tell us that 130 have black. Okay, so you see with Venn diagrams, the thing about it is you should always start from the intersection. And this is the reason why. If you don't start from the intersection, it makes it really complicated. When they say 130 have black patches, they actually mean 130 in total have black patches. Okay. Regardless of whether they have brown patches, they have black patches. So you also have cows here that have black and brown patches. But because they have black patches, they're going to be included in this 130. So this is the reason why you need to start with the intersection. So that's what we're going to do. So X cattle have black and brown. So we'll put that in the middle. X is in the middle. And then to find out the total cows with only black patches, you're going to have to say this 130, which counts for every cow here. You're going to have to say that 130 minus the X, because the X in the middle counts for cows that have black and brown. And this part is just for the cows that only have black patches. So 130 minus X, and then brown. We have with brown patches 110. So you would also say 110 minus X, because we're just trying to see the cows that only have brown patches. Okay. And then they also told us about the ones that have neither. They said 5 cattle with neither black nor brown patches. So that goes outside. And there we go. This is what our Venn diagram looks like. Moving on to the next question. And now 3.2.2 says, calculate how many cattle have both black and brown patches. So remember that the black and brown patches, that is X, the intersection. Okay, so there's something we know about all of this. We know that if we found this amount here, okay, the cows with only black patches, and then you added it to this intersection, and then the ones with only brown patches, and then the 5, they would all add up to how many cows in total? We know that they are 200 cows. So we would say everything added up gives us 200. Okay, so let's add 130 minus X plus X, and then plus 110 minus X, and then plus 5 is equal to 200, and this would solve for X. Okay, do you see how we have negative X and positive X? They would cancel. And you have 130, 110, okay, so that's 240, and then plus 5 is 245. So then we just have 245 minus X is equal to 200, then transpose the X. So it becomes positive X is equal to 245 minus 200. And so finally, X is simply equal to 45. And that is our answer. Okay, moving on to the next question. Question 3.2.3, I think that's the last question for this Venn diagram. We have determined the probability that if Paul randomly selected one Nguni cow from the 200 cattle, it would only have brown patches. So we're trying to find the probability of Paul selecting cows with only brown patches. Okay, only brown patches. So when you're looking at your Venn diagram, you want to select cows that have only brown. So this will not include the cows that have brown and black. So if you look at that, that is this part over here. Okay. But they did say they want this information as a probability. So we need to still express it like that. So this is 110 minus X. We know what X is now. It is 45. So the probability of only brown would be 110 minus 45, but then you still need to say over the total amount of cows that we have here, okay, which is 200. And then this would be the probability. Okay, so let's go ahead and get this. Okay, and that is 0.325. I'll just leave it as a fraction since, it became 3 decimals. And I don't want to round off to 2 decimal places. So let's just leave it at 13 over 40. And that is our answer expressed as a probability. Okay, moving on to the next question. Question 3.3 says, a learner must choose to do either mathematics or mathematical literacy. At a certain school, it is known that 60% of the learners are girls. Okay. The probability that a randomly chosen girl at the school does mathematical literacy is 55%. Okay, so of the 60% of the girls, the probability that she does maths lit is 55%. And then the probability that a randomly chosen boy, okay, at the school does maths lit is 65%. Represent the information on a tree diagram. Okay, so with the way this looks, they are giving you information about whether these learners do maths lit or maths, right? But they specifically say that at this school, 60% of the learners are girls. And then from that 60%, okay, 55% of them do maths lit. So clearly, we have two categories first, where we have girls and then boys. And we know that in the school, 60% are girls. So we're going to look at it like this. We'll just say the girls, we have 60%, or you can just say 60 over 100. I'll leave it at 60%, it's fine. And then boys would be the remaining 40%. Okay. Now we look at each branch. So from this 60%, they said the probability that a randomly chosen girl at the school does mathematical literacy is 55%. So that she does maths lit, we can just say ML, that is 55%. And so that would mean the probability that a girl does maths would be the remaining 45%. So that is 45%. And then they also tell us about the boy. So they said that probability of randomly choosing a boy at the school that does maths lit is 65%. So with the boys, probability that he does maths lit is 65%. So this is 65%. Okay, or you can say over 100, that's fine. And so that means that the probability that a boy would do maths would be the remaining 35%. Okay, so this is what our tree diagram looks like. You can actually write it as 60 over 100. That's also fine. Okay, so this is what we have. And then we can just put the outcomes here. So you're just going to say, these are my outcomes, because that would be your complete Venn diagram. We don't really have to do calculations. If you do calculations, then, they're going to definitely ask you questions about it. So there's no use of doing that. So look at the outcomes that we can get. So when we're looking at this data, we can find the probability of randomly picking a girl who does maths lit. And that probability would be, we would say, it's a girl who does maths lit. So girl and maths lit. And then you would take those probabilities and you would multiply them. So I just want to see all the outcomes that we get here. And then we could also find the probability of choosing a girl who does pure maths. So that is girl and maths. And then we're done with that branch. Then we will look at the probability of choosing a boy who does maths lit. And that's going to be boy and maths lit. Let me just put it in the same line so we don't get confused. And then lastly, boy and pure maths. Okay. If they ask for the calculations, we will look for them and then actually just calculate it. And that is our Venn diagram. Moving on to the next question. Okay, question 3.3.2. The last question for this paper says, determine the probability that a learner selected at random does mathematics. Okay, so you see how they say that a learner does mathematics. They're not saying that the learner is a girl and does mathematics or is a boy and does mathematics. They say just does mathematics. So that means you need to consider both cases. We need to consider if this is a case of a girl who does mathematics, and you don't really look at it just like this. You look at it from your outcomes. So what we are considering is a girl who does mathematics, or we could even take a boy who does mathematics. We're going to take those outcomes, right? And we will add them. Notice the use of the word or. Okay, so I said, if we are trying to look for learners or learners who just do mathematics, we're saying we can either take a girl who does mathematics or a boy who does mathematics, okay? Or would mean to add. It increases the chance of something happening. Okay, so let's go ahead and find that. We'll say the probability of a girl who does mathematics, plus the probability, or you can say or, it's fine, and then probability of, okay, so and a boy who does mathematics. Okay, so you can just say or first and let's find this. So probability of a girl who does mathematics, we'll just go to girl, that's 60%, who does mathematics, and 45%. So when we are moving along the branches like this, we multiply because these things are jointly happening. Okay, so we are saying 60% as a percentage, let's just write it as a decimal, 0.60 multiplied by 0.45, and then plus and probability of boy who does mathematics, that is 40%, and he does mathematics, so 35. So that is 0.40 multiplied by 0.35, and this will give us our answer. For the sake of calculation, just because it's 3 marks, I feel like they're giving you a mark for seeing this answer, and then maybe the final answer. Probably not, it's 3 marks, but I'm still going to find them individually first. Okay, so you see that gives us 0.27. Then we're just going to say plus and say 0.40 times 0.35, and that gives us 0.14. So finally, add them together. So 0.27, and that gives us 0.41. Or we could even say 41% if you like. And that is our answer. Okay, this, or you can say 41%. And that is it for that question. And that is it for question 3. Okay, so that was a short test. That is the end of this paper. Okay, I hope you guys enjoyed it. If you have questions, please feel free to leave them in the comment section below. And I will see you guys in the future videos.